Welcome learners, I am Dr. Prabhat Dwivedi, Associate Professor STEP-HBTI, Kanpur, India. Today I am going to discuss with you t-test for one sample. In earlier lectures you have learned how z-test for different conditions can be applicable. Let's see what is the t-test, how t-test can be applicable, what types of t-test. So today I am going to discuss with you t-test especially for one sample, and rest of others will be next lectures. So first we will peep into the history of the t-test, like who developed it. So this was William S. Gossett who developed t-statistic, and in fact for the first time he published with his pseudonym as student. That's why it is also called student t-test for t-distribution. So this was just a historical point which I told you. Now let's see how many types of t-tests are. So main t-tests are of three types. One t-test one sample, another one is t-test for two sample mean, and the third one is paired t-test. So t-test for one sample in fact compares sample mean with the population mean, whereas t-test for two sample compares two sample means compares with means of the two samples with each other. So that is what they are, tests for equality of the means. That is what t-test for two sample is. Paired t-test in fact compares means, two means but of the same sample, the values of which have been recorded in different time zone, a different time, then you can compare. So that's why in that condition we apply paired t-test when sample is only one, but values are recorded for that sample twice in different times. So that is what are three main types of t-tests are. Let's see how t statistic for one sample is all about, and how this statistic goes. So t statistic or t-test for one sample is used to examine the mean difference between the sample mean and the known value of population mean. Just keep in your mind, population mean value is known and sample mean value is calculated, then both the values are compared. In fact, let me remind you that was the same which we were doing in z-test one sample, but there was only one difference, one difference, that z-test was applicable for a large sample, whereas t-test is applicable for small sample. And we know very well what is the small sample, what is the large sample. However, I would definitely like to remind you here, and now let's compare with the z-test and t-test, taking assumptions. What are the assumptions of t-test, whereas what are the assumptions of z-test? So let's take one by one assumption of t-test and z-test. So first thing is that which decide which test statistic will be applicable is the size of the sample. When size of the sample is below 30, this becomes a small sample, and in this case z-test cannot be applicable, only t-test can be applicable. Whereas if the sample size is 30 or more than that, the sample is called large sample, and in that case z-test can be applicable if it meets other conditions as well. Another point which is worth considering in deciding which test statistic will be applicable is what is given in terms of population standard deviation. If population standard deviation is unknown, t-test can be performed. But if population standard deviation is known, z-test can be performed. Third point is that population should be normally distributed, which is required for both whether t-test or z-test, and data points should be independent of each other, and which is required for both the cases. Another last point, but not the least, is the sample or samples should be randomly selected. This is the point, again, of great importance, whether the samples are randomly selected or not. So this should also meet, but that's requirement for both types of tests, whether T or Z. Now let's see what the test statistic, t-test statistic for one sample is. The t-test statistic for one sample is x bar, that is sample mean, x bar, that is sample mean, minus mu. Mu is population mean. So sample mean minus population mean. This is what the difference which I told you earlier about test statistic. Test statistic is equal to difference upon standard error. So here in numerator we can see there is a difference between sample mean, that is x bar, minus population mean, that is mu, divided by standard error, that is sample standard deviation upon under root sample size, that is under root n. So terms in this test statistic hope are clear with you, learners. What are they? Sample mean x bar minus population mean, that is mu, upon S, that is sample standard deviation, upon under root n, that is sample size. This is what the test statistic, t-test statistic is. Now let's compare with t statistic with z statistic. So here t statistic and z statistic is given for comparison. Now t-test statistic is like x bar minus mu upon S upon root n, whereas z statistic is x bar minus mu upon sigma upon root n. So the main difference is that is S and sigma. S is sample standard deviation, where sigma is population standard deviation. In case sample size is less than 30 and sample standard deviation is given, t-test can be applicable. Whereas when the sample size is large and population standard deviation, that is sigma, is known, z-test is applicable. But here, learners, I would like to remind you of one important thing, which is that many a time when population standard deviation, that is sigma, is not given to us, however, we apply z-test in case of the large sample. Why? Because if the sample is large, even the sample standard deviation works equally good as population standard deviation. So that's why, learners, I would like to remind you, doesn't matter if population standard deviation is not given for a large sample, then you compute sample standard deviation and put that sample standard deviation value at the place of population standard deviation, that is sigma, and compute with z statistic. That is important thing which I wanted to tell you. Now let's see what hypothesis, how hypothesis can be formulated. Like in z-test one sample, we formulate the hypothesis, that is, there is no difference between sample mean and population mean, learners. In other terms, sample mean is equal to the population mean. Mathematical terms of this null and alternate hypothesis goes like null hypothesis is mu equal to x bar, that is population mean equal to sample mean. Against this null hypothesis we can formulate three types of alternative hypothesis. That is one possibility or one option, that is mu is not equal to x bar. That is population mean is not equal to sample mean. And for this alternative hypothesis we compute two-tailed test. You may be remembering it. In case alternative hypothesis is with greater than sign, we compute a right tail test. And in case alternative hypothesis is with lesser than sign, we compute left tail test. Learners, I am telling you this again and again so that there may not be any possibility for you to forget. So that is what null and alternative hypotheses are in this case. Let's see how we work out a problem of t-test with one sample mean. The problem goes like past sales data of a company indicates that the average sales was $90 per transaction. Now the company wanted to improve its sales, so it organized a sales training program for its sales force. After training the sales force, recent sales data taken from sample of 16 salespersons indicates an average sales of $120 with a standard deviation of $12. It is the hypothesis that the training worked effectively at 5% level of significance. Let's see, learners, what values are given in this problem. Now, let's see the problem again. Past sales data of a company indicate that the average sales was 90 per transaction. This is record. So that becomes population mean. So $90 is a population mean. Now the company wanted to improve its sales, so it organized a sales training program for its sales force. After training, a training program was executed. The sales force recent sales data taken from sample of 16 salesperson. This is value of n. This is value of x bar. Indicates an average sales of 120. This is sample mean. Sorry, let me correct it. Here 90 is population mean. Now let's see in the problem. Once again what values are given to us. Now for that we should read the problem again. Past sales data of a Well, now we will see the problem again to see what different data or what different values are given to us in this problem. So the values given to us in this problem may be like past sales So learners, let's see the problem once again to see what values are given in this problem. Past sales data of a company indicate that the average sales was 90 per transaction. This is the record which shows that the average sales is 90 per transaction. That means this 90 per transaction average sales is population mean. So this value is mu. Now the company wanted to improve its sales, so it organized a sales training program for its sales force. After training, a training program was organized. After training of the sales force, recent sales data taken from sample of 16 salespersons. That means sample size n. So 16 is n. Indicates an average sales of $120. So this value is sample mean, that is x bar, with a standard deviation of $12. This is value of sample standard deviation, that is s. Test the hypothesis that the training worked effectively. Training worked effectively, that means positive impact of training. That means right tail test at the 5% level of significance. So this is a value of alpha. So let's see how we will put these values in test statistic and how we will compute it. So before that, let's proceed with the process of hypothesis testing step by step. Step 1 of hypothesis testing is to state null and alternative hypothesis. So null hypothesis here is that mu is equal to 90. Mu is equal to 90 is null hypothesis. Against that, the alternative hypothesis is mu is greater than 90. In step 2, we state level of significance that is given to us, and that is 5% level of significance. So that's also given to us. And in step 3, what we do, we compute critical value. So critical value computation goes like, since n is 16, that is below 30, so t-test is applicable. And alternative hypothesis is with greater than sign, that means right tail test. Critical value of t is at level of significance 5% with degree of freedom. Degree of freedom is, learners, sample size minus 1. So 16 minus 1, that is 15. So here the computed value of t is, critical value of t is 1.753. Let's see how we have found this 1.753 in next slide. Here we can see this is at the top circle, that is level of significance, which is 5%. In the column degree of freedom, that is 15%. So we see the intersection of both the values. Intersection of both the values shows 1.753. So that is what the value of critical value of t. That is to show you just. Now see, let's see how we compute the test statistic t. T is equal to x bar minus mu upon s upon root n. We put all the values given to us, and finally we found the value of t calculated is 10. Let's go to the step 5, learners, where we will see how decision can be made and conclusions can be drawn. So in that step we compare actually the t calculated value with t critical value. So here we find that t calculated value is 10 that we have already computed, and t critical is 1.75. So when we compare, we find that t calculated is greater than t critical. So the decision will be written as, since the calculated value of t is greater than the critical value of t, so it falls in the rejection region. Hence, we reject the null hypothesis. Now the conclusion will be written as, there are enough evidences to support the alternative hypothesis, so we can conclude that the training was effective. That means the mean sales contribution achieved from the sample, that was in fact 120, is not by chance. This is because of the training which salespeople have got. That means the training was effective. So learners, we have seen this problem worked out over here. Now let's see another problem which you will do your own. Problem goes like, an automobile tire manufacturer claims that average life of a particular grade of tire is more than 20,000 kilometers when used under normal conditions. A random sample of 16 tires was tested. A mean of 22,000 kilometers and a standard deviation of 5,000 kilometers were computed. Sample mean, sample standard deviation. 16 tires means sample size. Assuming the life of the tires to be approximately normally distributed, test whether the manufacturer's claim is valid at 5% level of significance. So this problem is for you. I suppose you'll do it at home. And I would recommend you to do other problems as well, so that you can be better in solving the problems related to t-test. So learners, I think, or I expect that you may have found this video lecture worth, and if it is so, I think you would not hesitate in subscribing, sharing and liking this video lecture, because knowledge sharing is very, very pious thing. Thank you so much.